want to start out by letting you know something about me. Math was never easy for me. Math was actually really hard my whole life. Through elementary school, middle school, high school, college, math was tough. It seemed like no matter how hard I tried, I just couldn't understand. So, with that being said, I want to give you a little insight as an elementary school teacher. I hear parents say all the time, I don't understand the new math. Why did we have to take a good thing and change it? Well, here's the truth. Suddenly, since I started teaching, math isn't hard anymore. It makes sense. And I know that they say the best way to learn something is to teach it, and while there is some truth in that, honestly, it's because of the foundational skills that we are teaching our students today that math isn't this abstract thought anymore. It's concrete. It makes sense. It's not this confusing mix of algorithms. Kids understand why. Why, when you do this to this number, does this happen? They see the cause and effect. So, with that being said, tonight I want to dive in super quick to the very basics of new addition. This is an equation, pretty basic. 3 plus 2 equals 5. That's easy for us. As adults, we understand. For a child, though, this is a little more complicated. So, for a kid, we do a number of things with an equation like this. For starters, we give a word to the symbols. Plus becomes the word and, equals becomes the word is. So we take away the abstract behind this equation. So a child would read 3 and 2 is 5. 3 and 2 is 5. Then we tell them stories about it. I had 3 cookies. I got 2 more cookies. Now I have 5 cookies. But this is not where a kindergartner would start. While kindergartners are exposed to equations like that from the beginning of the school year, they don't begin working with equations like that right away. They do begin working with a lot of stories like I just told you. Okay, I want to show you a couple of things for today, only 2, that a kindergartner will use when they are beginning addition. Okay, what we have here is a 5 frame, and it's called it that for the super complicated reason that it has 1, 2, 3, 4, 5 boxes that look like frames. Okay, maybe not that complicated. A 5 frame is something that kindergartners will interact with to work on addition within 5. So it could look like this. I had 1 teddy bear. My friend came over, sorry, I'm so shaky on this camera, and gave me 2 more teddy bears. How many teddy bears do I have now? 3. I have 3 teddy bears. It could also look like this. I have 4 hair bows, but I want 5 hair bows. How many more hair bows do I need to have 5? This is a quick visual way to say, okay, I know I have 4 hair bows. I want 5. I need 1 more because 4 and 1 make 5. Students also begin to work with that on a number line. We could say, I have 1 cookie. I want 4 cookies. How many more cookies do I need to have 4? Students can say 1, 2, 3. I need 3 more cookies to have 4 because 1 and 3 make 4. That's getting harder. First, students can also use their hands. Hands are a great tool for learning how to add. 1 and 2 more equals 3. Now, additionally, there is a strategy called counting on, which is where students do the math more in their head and maybe use their fingers. So it might look like this. I had 5 teddy bears. The neighbor gave me 2 more teddy bears. How many teddy bears do I have all together? Your student might say 5, 6, 7. I have 7 teddy bears all together. Now, I have mentioned that I would try to provide games and activities that you could play. So this is a math game that my students love for addition. that you can create and play at home with your. This game is called Inside Outside Addition, and what you need is a piece of paper that you draw a circle on, write a plus sign and an equal sign, and you need some small toys. I'm going to use my son's Legos. You also need to cut some cards out of paper and number them off. I'm using the numbers 0 through 5, but you can play this probably when it go above 10. So what you do is you take your toys, you shake them up in your hands, give it that fun effect, and you just drop them. Now, what you do is you add the toys that landed in the circle to the toys that landed outside the circle. So I have 3 outside the circle. I'm going to take my 3 and put it here. And 2 that landed inside the circle. I'm going to take my 2 and put it here. And now I have to come up with the sum, or the total. So 3 plus 2 equals 5. So one more time. Clear everything away. Shake them up. Drop them. This time they all landed out of the circle. So I would say 5 plus 0 equals 5. My students really like this game. I'm sure your kids would too, and it takes very little time or energy to prep. Okay, now I want to talk about some of the things I see with my 3rd grade students when the work gets a little bit harder and we have to work with some regrouping. So I'm going to show you an equation and just kind of talk to you about it. This equation here is what we call standard algorithm. When I was a kid, this is what we went straight to in math. I knew that 6 plus 6 equals 12, and I was taught to carry that 1 and then to add this column here. So I would get a total of 122. Well, I made some silly mistakes with that kind of math when I was a kid, and my 3rd graders make the same silly mistakes. So what I see, and this time, I've drawn a line down the equation to show that these are my 1s, these are my 10s. What I see my students doing is saying 6 plus 6 equals 12, 5 plus 6 equals 11. They are telling me that 56 plus 66 equals 1,112. That is not correct. This is showing a problem with place value, a problem with regrouping, that lack of understanding. Something else I see students do is if there was a hundreds place, they might carry from here to here and then forget to do anything here. Just a lot of confusion. So we have to teach kids what this looks like when you regroup. And I'm going to show you how we do that. Here's our problem again. I'm going to bring in my base 10 blocks, which I bought. So they came in on Amazon. Thank you, Amazon, for delivering through all of this. Okay. I'm going to start out by building 56. 1, 2, 3, 4, 5. These are my 10s. 10, 20, 30, 40, 50, 51, 52, 53, 54, 55, 56. Now I'm going to build 66. Maybe not. I don't know if I have enough. Let's see. 10, 20, 30, 40, 50, 60. I do. Perfect. Okay. 61, 62, 63, 64, 65, 66. It's really important, just like with that standard algorithm, that we start out by combining our 1s. So I'm going to take all my 1s and put them together and count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This 10 is that same thing as carrying the 1, carrying the 1. It's actually not carrying a 1, it's carrying the 10. I can take that away and replace it with a 10. This is still equal to 12, just like that 6 plus 6 was. Sorry, grammar. Okay, now I'm going to combine all my 10s. Move these off to the side. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 121, 22, 122. So what I did is I still added this up and got 12. But this is the 1s column. So I can't put a 10 here. So I can only put my ones. I had to carry that 110 and put it in the tens column to get that 12, which is the same as saying 122. Get confused? That's okay, because I don't do that in one day with my students either. We go through the base 10 blocks a lot, and we talk about place value and what it all means, just like I did in that crash course the other day. So I'll show you one more time, and then I'll show you how you can do this work at home with your students. In my place value video, I showed you these base 10 blocks, but I didn't have any, so I drew them out. Well, now I can show you just a little bit to help you understand what happens when you regroup. Each of these is worth 1. One individual little cube. These rods are worth 10. There's 10 notches in them, worth 10. This square is worth 100. It's 10 tens stuck together. So if students are adding, let's say 9 plus 4, they would make their piles 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 plus 4. 1, 2, 3, 4. Then they would put that all together. Now they're going to look for a 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This can be replaced by this. Now students can easily see that 9 plus 4 is 13. Now, if you're anything like me, you don't have base 10 blocks at home, and that's okay. I'm going to show you what you can do to help your students work through regrouping at home without base 10 blocks. Here is an equation, 157 plus 63. The first thing you're going to want your student to do is write this vertically and line up the place value. I have my third graders who struggle with this draw those lines that separate the place values. This way they can clearly see their ones, tens, 100s. Now, right off the jump, 7 and 3 make 10. So a student might try to write a 10 here. You can have them try to solve this and carry, but for starters, you might want to have them draw out your base 10 blocks. Let's start with 157. Remember, the square represents 100. Rods represent tens, or you can just draw lines. 1, 2, 3, 4, 5, and 7 ones. You can draw little squares or just draw dots. 1, 2, 3, 4, 5, 6, 7. Plus 63. I don't need 100 here, so I'm going to draw 6 tens, 10, 20, 30, 40, 50, 60. And 3 ones. 1, 2, 3. So we start out in the ones place, just like you would start here. We're looking for a 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what I'd have my students do, and I'm so not good at this, is circle that, because that makes a 10. And they're going to add this to the tens. So we're going to see now if these tens make a 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have more than 10, so we do have a 100. So we're going to count out 10 and circle them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't want to get lost here. This is really hard to do and video at the same time. I should get my son to video for me. So now I can see what I have left is 100, 200, 10, 20. So I have 2 in the hundreds place, 2 in the tens place, and 0 ones. 220. So I hope that you have a better understanding of the new addition and why we break things down so far. It's really to serve a purpose of helping kids understand the why and not just the how.